Hello, it's Mrs. Allison. Today we are going to look at graphing vertex form. So let's get started. Our equation for vertex form is the equation y equals a, and this is the same a that was in our standard form, and then parentheses x minus h quantity squared, meaning we're squaring x minus h the whole thing, plus k. All right, the nice thing about vertex form is it's really only 3 steps that we need to actually do, and one that we can use as a verification of what's happening in our graph. So let's start. First thing we want to do is be able to identify our vertex. Our vertex is the ordered pair h, comma, k. Because remember, a point on the graph is always an ordered pair. All right, there's a couple of things I want you to be aware of. I'm going to put a little asterisk here. Oftentimes, it is easier for us to think of this as the opposite. Remember, opposite means negative, or the sign has changed. The opposite of h. The reason it's easier for us to think of it as the opposite of h is because our brains do not like negative signs in formulas. And we have a negative sign right there. We don't like them. So we need to look at that and recognize that that's going to change the actual sign of what was in there. So the opposite of h and k. Now, one of the things that's nice about vertex form is we can look at the equation and know what our vertex is, which means we also know what our axis of symmetry is. Remember, our axis of symmetry is the equation x equals, and in this case it's the same h value that we had up here. The axis of symmetry, or the vertex, is always on the axis of symmetry. So it's the same h value we have. Now, we need to be able to look at our a value of the function and determine what it tells us. Remember that if a is a positive number, then the parabola will be facing right side up. And if a is a negative number, the parabola will be facing upside down. Okay, now to the one part that will determine what our graph really looks like. Having the axis of symmetry and the vertex is perfect, we need that, but we don't have a really good picture of what this graph is supposed to look like. So we're going to look at our next points, and remember, this is still a parabola, so it is still symmetrical about the axis of symmetry. So for our next points, what we're going to do, just like on standard form, is we are going to pick the x value that is either to the left or to the right of the axis of symmetry and plug it in. And then we're going to mirror image it again. That's the advantage of having a symmetrical graph. All right, so we are going to go through these 4 steps on one problem on the next slide and see how we can do with graphing in vertex form. Okay, so let's look at the equation y equals x plus 1 quantity squared minus 2. What I'm going to do is I'm just going to write above this, hopefully write vertex form, just as a reminder, so we can remember what our pieces are. So let's start with our vertex. Remember, our vertex is an ordered pair, and our ordered pair is h, k. Now we like to think of it as the opposite of h because we see this positive sign and we want the number to be positive, but our formula tells us it's supposed to be negative. So the number that gave us a positive 1 is actually a negative 1. All right. And then we go on and we look at the y value or the k value in the equation of the one that's given, and that is the y value of our vertex, and that happens to be -2. So I am graphing the point -1, -2. Now, I actually think it would be better to have the axis of symmetry at the same time as the vertex. So before I plot the vertex point, I'm actually going to find my axis of symmetry, which is nice and easy because it is the same value as that h value right there. So that is -1. Let's rewrite that. Can't tell it says -1. X equals -1. All right, so now I'm going to graph my axis of symmetry as a vertical line through x equals -1. And I am going to plot the point -1, -2 on my graph. Okay. What does the a value tell us? Well, this a value happens to be 1. We didn't list it, but we can see it written in front of the parentheses. There isn't a number there, which means that that value has to be 1. And since 1 is a positive number, I know my graph should be facing right side up. So let's move on to step 4 and see if finding our next points proves that the graph is right side up. Okay, so for my next points, I have the option of picking either -2 or 0 as my x value. I always default to 0 if I can, because 0 is just an easy number to use. So I'm going to go back into the equation that was given that looked like this, and every place there was an x, I'm going to put 0. And now I'm going to do good algebra using order of operations to get that y will be 1 squared minus 2. And then y is 1 minus 2, which means it's -1. So my next point is the ordered pair 0, -1. So if I plot that point on my graph, oops, it's hard to graph on this, and then mirror image it over, now I have enough to tell me what my graph should look like, and I can sketch a nice smooth curve that goes through those 3 points. So as you can see, vertex form is a little easier to graph or to go through the steps than is standard form, but the end result should look the same. Thanks, guys.